Have you ever wondered how computers think? They use a tiny but powerful device, the CPU or Central Processing Unit. You can think of it as the brain of your computer, phone, and even your gaming console. Making these CPUs is a complex journey that starts with something you find at the beach. Sand. CPUs rely on a special material called silicon. Silicon is a semiconductor, which means it can control electricity flow in a special way. And guess what? Sand is a great source of silicon. First, we need to extract the silicon from the sand. This involves heating the sand to really high temperatures. Then it goes through several chemical processes to remove impurities. What we want is ultra-pure silicon. Think of it like removing all the unwanted bits from the cookie dough to get the tastiest cookies. The purified silicon is then melted and grown into a large cylindrical crystal. This crystal is sliced into thin, round discs called wafers. These wafers are incredibly smooth and pure, ready for the next stage. Now comes the really cool part, creating the intricate circuits on the silicon wafers. We use a process called photolithography, which is like using a super tiny stamp to print the CPU's blueprint onto the wafer. Imagine shining a light through a stencil onto a special kind of paper that changes when exposed to light. That's similar to how photolithography works. This process creates the transistors, the tiny switches that control the flow of electricity. Millions, even billions of transistors are etched onto a single chip. Section 4, creating the circuits. Next, we need to create the actual circuits on the wafer. This involves a two-step process, etching and ion implantation. Etching is like using a tiny chisel to carve out the areas where the circuits will be. Then, in ion implantation, we bombard the wafer with ions, which are atoms with an electrical charge. This changes the electrical properties of the silicon in specific areas, creating the pathways for electricity to flow. Section 5. Building a chip layer by layer. Making a CPU is like building a skyscraper, layer by layer. The processes of photolithography, etching, and ion implantation are repeated many times, creating multiple layers of circuits on top of each other. These layers are connected with tiny wires, forming an incredibly complex three-dimensional network of transistors and circuits. It's like weaving a super intricate electronic tapestry. Section 6. Testing and packaging the brains. Finally, the wafer is cut into individual CPU chips. Each chip undergoes rigorous testing to ensure it functions perfectly. Only the chips that pass all the tests are sent for packaging. In the packaging stage, the chip is placed inside a protective case with tiny wires connecting it to the pins that will interface with the motherboard. The packaged CPU is now ready to be shipped to computer manufacturers and finally make its way into your devices. From a handful of sand to a powerful CPU, the journey is a testament to human ingenuity. These tiny chips power our digital world, enabling us to connect, create, and explore like never before. So next time you use your phone or computer, take a moment to appreciate the incredible journey of the CPU, from sand to silicon.